I'll just introduce you first and introduce the topic. And we can always crop out anything in the beginning that doesn't really belong right in. Okay. Okay. Our esteemed guest for this event is Jaan Tallinn, accomplished and well-known entrepreneur, investor, and theoretical physicist from Estonia, who co-founded the peer-to-peer video calling service Skype, among other ventures. He's since been a leading voice on the frontiers of AI safety and effective altruism, and has co-founded the Center for the Study of Existential Risk and the Future of Life Institute. Welcome, Jaan, and thanks for agreeing to give us your time today, despite your very busy travel schedule. Now, hi. As you may know, at the Carbon Copies Foundation, we usually focus on the technical challenges for whole brain emulation. And occasionally we explain why we think mind uploading through whole brain emulation is an important step for the adaptability of an intelligent species. But everyone at the Foundation is also very interested in artificial intelligence and artificial general intelligence. But since there are already so many labs and companies like DeepMind, groups like the Machine Intelligence Research Institute, and others dedicated to AI, we don't often address it in our workshops. But we decided that the interaction between those two domains should be addressed explicitly. The possible interactions are sometimes alluded to, but from what I've heard and read so far, there's a lot more vague hand-waving, I would say, than careful study. So we wanted to try to move that along a little bit, especially starting with this workshop on whole brain emulation and AI safety. So if you don't mind, I'd love to ask you a few questions about your thoughts on AI, and from there, maybe we can gently tiptoe into questions of where AI and whole brain emulation meet. Is that okay?
Sure. Sounds fun.
All right. So you've got a long history of being concerned about or supporting serious study of existential risk, and in particular AI risk and AI safety. Would you mind telling us a little bit about how your thoughts on that topic have evolved over time and where you stand on that today?
Yeah, I think my thoughts have gotten more and more uncertain in some sense, as I've been kind of exposed to more and more considerations and like more research has actually come out, and also like there have been kind of particular achievements that AI has made, or progress that AI has made in the last
When you say
decade.
More concerned or more uncertain, do you mean you're more concerned, or just that you're not entirely sure what the problem is?
Yeah, like I see like a wider spectrum of possible scenarios now, than I was just seeing when I first got involved. I mean, before I got involved, before I read like Eliezer stuff, I just didn't think that was an issue at all. Like I was a programmer, and I wasn't afraid of programs. So, but like then Eliezer pointed out, like, wait a minute, like if you can create a program that's able to create program, and that happens to be get smarter at each step, like we might have a serious problem. And then I focused on that scenario, and I still think that this is like we have no guarantee against that, recursive self-improving runaway AI. However, recently I think Open Philanthropy project, they introduced the concept of transformative AI. So instead of talking about like recursive self-improving AI or narrow and general AI, which are in some sense actually specific, we should actually just focus on the aspect of AI that is important for us, which is like it can be very transformative, even if it's narrow or if it's like not recursively self-improving. It's just for some reason exceeds some threshold and then no longer improves, but still is going to be transformative. So that's like, in that sense, I see like a wider spectrum of transformative situations or transformative scenarios with AI now, which is in that sense, I'm more uncertain.
Yeah. So, okay, we could go in all kinds of directions with this, and I don't want to spend too much time on it just because we have these other topics that are really the focus of the workshop that's going to happen. But I am kind of curious, because you mentioned this, getting real advantages for the species, for all of us, out of narrow AI, out of certain directions. Narrow AI itself also could pose concerns, right? I mean, we've seen some issues with narrow AI even in recent times, like the way that a stock market crash could happen or other things like that, right?
Or the Facebook scandals that they are like they have to do something with AI, although
Yeah,
I'm not
yeah,
sure how much, but still.
indeed, yeah, yeah. Okay, but it's not as concerning as, say, the issue of AI agents to you, probably.
I mean, not the current things, but like perhaps like in a few generations from now, we might have something that is just like super manipulative or super addictive, while not being kind of like really good at that kind of recursive self-improving. So it's still like that kind of scenarios. They still are kind of part of my palette.
Okay. Well, if you don't mind, I'd love to know what your idea is of, say, a worst case scenario versus a best case scenario of how we move forward with AI.
Yeah, so like I get that question quite a bit, and I usually don't have a sort of very specific answer because I think that whenever you start thinking about really specific scenarios, like you're almost guaranteed to shoot yourself in the foot because like it's like the each detail basically will make the scenario less likely. Uh,
Mm.
so I think it's more valuable to think about general properties or traits that like really positive scenarios or really negative scenarios have in common. So for example, I think almost all existential risk scenarios, be they from AI, from synthetic bio, even from nuclear, although I think that nuclear is kind of unlikely to be existential catastrophe. Uh, they have this one of the traits that I think they have in common is that they're going to look like environmental catastrophes to humans. And that's like there's interesting like point that the first piece of existential risk research that humanity did was the report LA602 by Manhattan Project scientists,
Hmm.
where they're gonna were calculating what is the probability of igniting the atmosphere once they do the first nuclear detonation. So like for the rest of the planet, it would have just looked like an environmental catastrophe. Like suddenly there's no air to breathe. So I think that that's like one likely common trait in not all, but I would say majority of existential risk scenarios, bad
Hmm.
scenarios. Like the existential hoop scenarios, one of the traits that I can think of they have in common is that there's an increase rather than decrease in optionality. So like one thing that technological progress has given us is this increase in optionality. Like I do have an option to like easily visit other countries these days that like 100 years ago very few people had, or like at least not that in that quantity. Whereas in future, if things go well, we might indeed have options to travel to other places or options to upload ourselves or not upload ourselves. That's also an important option to
Hmm.
keep. So like
Of
that's
course.
another common trait. I think that positive that's another common trait that unifies like a set of futures and specifically a set of positive futures.
Hmm. Yeah, I can totally see yeah, the point that you're making, because I mean I also see optionality as being one of the most important things for us. It's sort of a something that for some reason as human beings we care about that sort of thing. We care about
I think that's more general than human. I think that's agents in general that have
mm,
preferences over the world states. Like all other things being equal, they would prefer more options than less options because of the uncertainty that they have. Like things like it's a meta value. If you have certain
mhm,
preferences, but you don't know what are the correct actions to take right now, then like it would be valuable to have more options because in the future you will have more information about what options are actually best
yeah.
to pick. So that's a I think general agent
It gets into some
value.
interesting sort of philosophical directions there, because when you think about having as many options as possible, then of course that includes things like options to do things that we currently simply can't do because maybe we can't even think that way. So something like neuroprosthesis or mind uploading would be necessary even to just be able to do those things. Like let's say, for example, be aware of and react to things that are happening at very short time intervals, like say microsecond intervals. It's a world that we currently can't live in, right? And
Yep.
so optionality might include changing who we are in a sense. And but that stands, well, it gets interesting because some people would say if we change ourselves a lot and we're not really who we are anymore as humans right now because we've changed a lot, then perhaps that's very similar to a scenario where, say, a worst case scenario that was mentioned, where suddenly the environment no longer supports humans as we are. You know, that there could
Yeah.
be
So
scenarios where that might look very similar.
I think it's important to kind of be more precise about what do we mean by optionality? How do we measure the increase in optionality? So like you can certainly have like a increase in optionality that one person or one group of people, like Manhattan Project scientists, have to detonate a potential like Earth-ending uh, device. That's an additional option for them, but that
Hmm.
might result in like everyone else losing all their options by going extinct. So in that sense, like a more general version of it is that like we should really measure some kind of like aggregate optionality
Yeah.
that humans and more generally sentient agents
But even
have
that's
about
very,
the
very
future.
difficult to measure because you might then argue that you should be measuring the aggregate over all possible future descendants of humans as opposed to just the people who are here. Because let's say
Yeah,
that something takes optionality away from 90% of the people, but then the 10% of the people who have more optionality, that creates a much greater future with more optionality for many more people than the alternative.
yeah, but we,
It's
we
very
will go
complicated.
into population ethics and infinite ethics even. That
Right,
is like
right.
active research topic, and it looks like we need to solve it sooner
Yeah,
rather
yeah.
than later.
Yeah, again, I'm saddened by the fact that we can't talk about every topic at length because these are super interesting things, and I've always wanted to dive deeper into
As
this
a meta
question
point,
of
like
how do you decide what's good,
yeah,
right? How do you
as
decide a good
as a
solution?
meta point, don't you find it like kind of almost suspicious that there's like a very strong overlap between like super interesting topics and super important topics? Like it's not obvious why it should be like that,
Okay.
but there is, which kind of makes me a little bit suspicious.
Yeah, that's suspicious. Yeah, yeah, that could point to something as well. That's true. Yeah. Okay. Well, I guess maybe we'll have to have another workshop someday on what is good or how do you decide good. But that
Yeah.
falls more into, say, the domain of affective altruism or something like that, I think,
Yeah,
than
but also
yeah.
I think it's like you can always kind of like make progress by going like up on the level of meta. So like you say like it seems really hard to decide like what is good. Then like then you go like up one level of meta. Go like okay, so what kind of things should I do now that would give me more optionality to decide in the future what is good, or
Hmm.
like what are the like for example at the recent conference in Puerto Rico, the Future of Life Institute uh, organized that there was like yeah someone who was kind of making a really good case that there's like it's probably going to be really likely that there's massive value in having like this contemplative period during which we basically kind of like as humanity think about what's going to happen in the next uh, like trillions of years as opposed to like just like rushing along with the first thing that comes to mind because it's like just we have like good reasons to think about that we're going to be better at making creating value during that period than
Hmm.
than we would be basically losing from not acting in this first period. That's another
Yeah.
meta point.
Yeah. I think that's probably true. It's unfortunate that when you look at the decision makers across the world, very often that's exactly not what happens. It's more the opposite, that the next
Yeah,
quarter is what matters the most.
but
Yeah.
that's also like gives like an opportunity because like you see like why this is happening. You see the game theoretic uh, underpinnings of these situations and once you can realize that you can perhaps take a step back and think about how do you solve those like what's called
Mhm.
coordination problems.
Okay. Well, having created this context and putting it in a setting like this, maybe this is a good moment to dive into the whole brain emulation aspect of it. So, just kind of introducing here where this is coming from. Uh, when discussed in the context of AI safety, I get different reactions to the notion of whole brain emulation sometimes. Sometimes people will be seeing it as a potential benefit, something good that will help us not have as much AI risk because humans will be able to keep up better, will be better integrated with a changing world of technology. But sometimes I get the exact opposite reaction, which is, well, whole brain emulation seems like something that adds another unknown. It adds something else that could accelerate the development of artificial general intelligence or agent AI, and that it could be its own risk in some sense as well, which kind of relates to what we were talking about before about, which changes on optionality are good and bad, and the sort of figuring out what the difference is there. So I was wondering if we can get into a few specific questions there, because there are some main avenues of thought or critiques that come up from time to time. So the first one that I wanted to ask about is this idea that making a connection between the human brain and a computer, so brain-computer interfaces, that is somehow a very important step towards uplifting us to a point where we are more integrated with machines, and where the gap is made smaller between human minds and artificial intelligence and the differences in our capabilities, that somehow this is going to create a symbiosis, as one well-known entrepreneur has said, with artificial intelligence. Have you thought about BCI? And I'm not, so just keeping that separate from neural prosthesis or mind uploading for a moment, but just BCI as a tool for that.
I guess like my clip answer would be that I really like Robin Hansen's comment about this. He said that trying to make humans competitive with computers by developing like brain-machine interfaces is like trying to make horses competitive with cars by developing stronger ropes. So like I wouldn't rule out that there is like something there. But like the bandwidth argument, I find just like utterly unconvincing because, like, if you think about it, like if you were kind of like partnered up with someone who is like runs 1 billion times slower than you do, then that's basically a person who can say one word per decade, and like it's just going to be a burden. It's not going to be like useful. You already know what the word is going to be. That are useless too.
Okay. Yeah, I think.
So that's the bandwidth.
Yeah.
That's the answer to the bandwidth argument. But so that's just not a bottleneck. That's the claim. But like there might be some more interesting arguments that I haven't heard. But like it's possible that I just haven't been paid attention to like some more serious thinkers in that space. That I can certainly kind of imagine that there are some more. We can certainly learn more things if you have like higher bandwidth interfaces, learn more about the brain, for example, and then that could be useful in brain uploading, for example, or it could be useful for other alignment purposes. Or it could not. I don't know.
I see brain-computer interfaces as an essential component for data acquisition, for learning about the brain, in order to be able to model brains, to be able to make neural prostheses and that sort of thing. So as a technology heading in that direction, absolutely, of course, it's very important. But yeah, I agree with you that in itself, that's not really solving a problem of this gap between the two.
Exactly.
So yeah, so I guess we don't have to get into that much deeper, since we're both on the same side with this one. I would like to hear someday from the people who do advocate that as being the most essential thing to do for AI safety. I'd like to understand where they're coming from or how they imagine this should work. So maybe,
sure. Like if there would be like some serious, careful thinkers in that area, that would be like super interesting to talk to.
Yeah. Okay. So the next critique or argument that I often get is that if you work hard on building neural prosthesis, and then from neural prosthesis or partial brain uploads, you end up getting to whole brain emulation or some kind of artificial brain like that, that this is in itself, of course, a type of artificial intelligence or artificial general intelligence, if you like, although other people would call it natural intelligence emulated, and that it would be fairly easy to make it superhuman just by, say, increasing the speed or something like that, or making sure that the memory is never fading, something like that. So then that there could also be some sort of takeoff scenario, either a slow one or a fast one. Now, I'm not exactly sure how self-improvement works with a human brain. I'm sure there is a method, and it may be a bit more patchy and a bit more complicated than with something that has one specific algorithm that is following. But before we even get into that, do you see ways in which whole brain emulation itself could be an existential risk to humanity?
Oh, sure. Like the way I sort of like, I haven't thought like much about it. So in that sense, my kind of thoughts are not super careful here. And so mostly I like to kind of like outsource my opinions to like more careful analysts like Carl Schulman. I think is like excellent in this topic, and he considers brain uploads as net positive. So in that sense, I'm working on priors that come from him. But I do think that there's like this almost like uncanny valley. Before we get the brain uploads, we will get to something that is potentially capable, but not really human yet. So
Yeah,
it's like we might have like a potentially very capable non-human agents on this planet, which is like almost isomorphic to unaligned AI problem. So that is like one scenario definitely that might be problematic. Another scenario is basically when it turns out that there's some kind of like competitive situation or something where you get some advantage in some competitive access by sacrificing a piece of humanity, piece of values, which means that like we have like some race to the bottom thing with brain uploads. That would also be another existential disaster potential. So like those like either like getting fake humans might be problematic, or ending up in some weird arms race would be problematic with brain uploads. But also like if we get things right, then that might be really awesome because we might just buy more time when it comes to solving problems that humanity faces.
Yeah. But it's clearly so complicated because there are so many different details about how the research evolves and how you get from the very first bits you're doing, say you're just making, like Ted Berger's hippocampal prosthesis or something like that, or you're trying to emulate the brain of a Drosophila. And what happens if you start building agents based on these Drosophila brains? There's so many different paths, as you said, that makes it a really complicated question of how do you make sure that you end up with a net positive of that versus you end up going down some path that has, risks associated with it. But of course, that's also true for any technology development. Every time we develop some new technology, there are many different possible outcomes and products and things that could have net negatives and net positives as well. It's just, it's too hard to... Okay, yeah. All right, so there definitely are some ways in which it could be an existential risk, but it's not that clear. Yeah. I was kind of curious about this case of, say, how could people using a neural prosthesis become an existential risk to all of us or something like that. But again, that sounds like a great sci-fi scenario. But
you have like this weird cyborgs.
Yeah, it's hard to
that
evaluate.
Speak in metallic voices. That's
yeah. But then you also again have to think, if this is again weighing optionality versus staying the same, and you mentioned competition, but what if that competition itself is something that has ultimately a long-term net positive or something like that? You have a species that is a little different than humans, but that ends up
technological competition seems to have given us a lot of fruits. That are clearly useful.
Okay, yeah. All right. We're actually making pretty good progress through these questions, even though I thought it could take forever to...
At least it's so long. I'm trying to kind of like...
not you're giving short answers. All right. Okay, well, that's good. Let's get into the next critique then, or the next argument. The next argument I've heard that cautions against a strong push for neurotechnology and whole brain emulation is that work in those areas may accelerate advancements towards runaway self-improving AI. And, well, does it concern you? And how do you see this difference, say, working on whole brain emulation versus just the way neuroscience is currently investigating the brain?
So, yeah, intuitively, it doesn't sound too dangerous to me. I think because there are sort of like lower hanging dangerous fruits, like just throwing more compute at the stuff, at simple algorithms that people are doing already anyway. and trying to like create AIs that create AIs that create AIs, like architecture search.
Mm-hmm.
Whereas like if you're kind of tinkering with something that is like a spaghetti code, uh, like and trying to get insights, that seems like possibly problematic, but like just doesn't come to me, doesn't strike me as like the most dangerous thing to do. You're like just digging around in a spaghetti code that is human brain.
Mm. Okay. Yeah, I was trying to think of examples of specific things that I might think that would be discovered by doing research on whole brain emulation, as opposed to the way that most neuroscience is conducted today. It's not obvious to me, even with things that are still problems in AI. Say, for example, that deep learning requires exponentially more learning as you try to train up more
Mhm.
complicated knowledge or a better understanding of context around it. That's something that we would love to understand better how it is that humans manage this, especially since we can only digest very few examples for everything that we learn.
Mhm.
Um, but it's
So yeah,
not
that,
really
that's
something, yeah,
there's definitely there's possibility to stumble upon that, but because it's human mind is a spaghetti code, it's just not
right.
super likely that we're going to
It's not
stumble
clear
upon that.
how you would learn this from trying to do whole brain emulation, right? Yeah, it's more
Yeah.
something that, cognitive science, AI research itself, something
Mhm.
like that is more likely to come across that solution.
Or
I
just like
think.
yeah, like AI itself is able to figure that out when it's doing architecture search. So it's like
Yeah,
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 if there's like a humans doing like kind of architecture reverse engineering on human minds, or AI doing architecture search in AI space, like my money would be on the AI right now. But
right,
like
yeah.
that
It's
might change in the future.
it can simply do so many more searches so much faster.
Yeah,
Yeah.
it's like dumber, way dumber search, but like evolution was even dumber
Mm,
still.
yeah, yeah. Yeah, I think so as well, yeah. Okay, that brings us to the fourth big argument, and this one is one in favor of whole brain emulation. And the idea is, of course, this idea of symbiosis, so the merger between what is, the human mind and the merger with AI and its capabilities, and the idea that you can reduce AI risk or the risk to us, in a sense, by being more closely integrated, completely entangled with everything that's going on in AI, so that a whole brain emulation, a mind uploaded person could benefit more directly from what is developed in AI because AI modules can be part of them or they can be part of it. It's kind of hard to describe because I don't really know how to imagine it, but it's sort of this join them rather than compete with them. This idea of, in the past, royal families used to marry among one another to avoid competition and to consolidate their
Mhm,
power.
mhm.
It's a mingling of a DNA in a sense, except that, you could say that this is alien DNA. It's AI DNA is somewhat
Yeah,
different than human DNA. Have you given some
I think
thought to what this merger might look like?
yeah, I think like you brought out the mixing with alien DNA, like DNA. Like we should be kind of like wary for a very similar reason. I mean, AI is going to be more alien than aliens. Like if you have biological aliens, they have like they're likely going to have similar eyes because like eyes have been invented at least on this planet
Mm-hmm.
many times, and like they're similar. So like there are pieces in that DNA that's going to be similar if you're going to merge with aliens. But even that would sounds like a little bit like icky to me, just to say the least. So like with AI, it should be way more icky, even though it doesn't feel as icky as merging with aliens.
Hmm.
And also, I think it doesn't strike me as a sufficiently rigorous thought exercise when you talk about like kind of solving a complicated problem by just ignoring most of it and just like doing something that feels intuitively warm.
Okay,
So
so
that's.
yeah.
But I mean, having said all that, I wouldn't kind of I would leave open the door for some serious thought
Hmm.
in this space, and perhaps people actually would come up with some interesting scenarios that involve things like transparency, for example.
Right. Oh,
How can we
transparency.
kind of
Yeah. Hmm.
how can
Yeah.
we kind of uh, make it more difficult for AIs that are improving to do like what Nick Bostrom calls treacherous turn, and the more kind of more ways we have to monitor them, the more difficult it would be to do that for AI. So it's like, and the better we would be kind of steering those critical in those critical phases. So that would be like one angle of attack, perhaps, that would be valuable in this like kind of merger scenarios.
Okay, yeah, so I completely agree that it's necessary to get more detail to think more rigorously about these examples, because what we're doing now, I mean, it's useful to discuss like this, but it's still kind of hand wavy. We're just sort of saying, in general, one could think of how the two can merge, and in general, we might think of how this might help in supervising how AI is developing and stuff like that. But when I try to think in real nitty-gritty detail about how AI and human minds can merge, then I start to think about things at a smaller scale, not the scale of an entire brain, but something like, okay, let's take an example. Because it's a real example, let's take Ted Berger's hippocampal prosthesis. Now, Ted Berger's hippocampal prosthesis, when implemented on either software or in a chip, it's really just a model that is or learning to approximate functions from input to output, and it's searching for those best matches and then using them to do what that piece of brain tissue is supposed to do. Now, there are many different ways you could implement that. And of course, even now, that's where AI comes in. He's using machine learning techniques to build those models. So there is a lot in which there are a lot of ways in which developments in AI can find a home in these pieces that are then developed as replacements for bits of the brain. It could be very small. It could be at the level of an individual neuron or an entire area. It could then lead to differences like, say, hippocampi that allow you to directly select which memories to keep and which ones to forget and that sort of thing. Or, you can imagine that there could be other ways of strengthening connections between different patterns than the normal Hebbian learning, but another way to do that. So I can see a lot of ways at this very fine scale where AI immediately starts to become integrated into neuroprosthesis and whole brain emulation, because it's just the natural way to try to solve these problems, to implement things in there. And that's the first part of it. And then the second part is where you would intentionally want to make it possible to feel that you have the capabilities of some AI system and that it feels as natural as, say, being able to retrieve something from your memory, so that it's like a part of your brain. And then you start to wonder, well, if these are the things that you would want to do anyway, if you're doing whole brain emulation, then how does that map into wanting to have some kind of safety valve on how AI develops? Because that's not automatic. That's not something that just evolves directly out of it. You would have to expressly try to make sure that the environment in which AI is developed is such that human minds have insight, as you say, transparency into what's going on. So that's still not really an automatic thing. It still feels like, even if you're trying to create this merger, because whole brain emulation uploaded minds are already closer to software code, and I mean they can be software code, and therefore you see this at a small fine detail. You see these mergers happening. It still feels like the problem of AI agents that self-improve rapidly and could go off in a wrong direction is kind of a tangential problem. Yeah. It's still something that needs to be explicitly dealt with and isn't automatically dealt with by having...
Not just like individual AI agents, but also like some weird races that we might create as like in this like whole brain emulation scenario. I think the same kind of threat model applies there. Like the opportunities is like kind of similar in kind of augmentation than in whole brain emulation, that we will just create smarter humans, and we definitely need smarter humans right now to figure out like how to actually stabilize the future. However, the threat model again is like we might be creating smart non-humans by doing careless augmenting. or we might create some weird race to the bottom in competitiveness, and basically then lose all optionality and all humanity.
Yeah, and that is what feels like not good to me when you say
for a very
race to the
correct
bottom.
reason. Yes,
Yeah,
yes.
exactly.
So yeah, like, but I definitely I do think that there is opportunity there in having just I mean simple thing is like I think as a lot of like augmentation advocates point to is that like we already augmented, right? So
Yeah, of course.
so in some sense it would be a natural progression, and so far it seems to be. I mean, with a few setbacks, like seems to be like so far so good. Now the question is like how much runway we still have until we have to be kind of like more careful and more planning when it comes to augmentation.
Okay. Yeah. Right. So we've run through pretty much all of the main questions, and
Awesome.
I do have a concluding question, but I wanted to ask first if there is something in this whole topic that you feel that we haven't addressed or haven't talked about that you think really should be mentioned.
Yeah, because like I haven't specifically spending a lot of time when it comes to augmenting and uploading humans. And by the way, like another kind of adjacent scenario that we like a pursuit of research, a research area that we haven't talked about for right reasons is basically genetic modifications and either kind of embryo selection or direct gene editing, which I mean kind of like a little bit outside of the scope, but it has like very similar, perhaps milder threats and opportunities than augmentation and brain uploads have. So that's another interesting kind of alternative to keep in mind. Like if you say that they want like augmentation for X, then like one question that you have to be prepared to answer is like, why not just like gene edit humans to get that X? Might be safer or might not, depends on
Right.
that X.
Yeah. I mean, there are probably a lot of things that you can't simply genetically modify humans to do.
Yeah, but the cool thing though is that it seems to be, like I said, like it seems to be like a milder version of augmentation, both in opportunities. There are fewer opportunities probably, and there are also like fewer threats because in some ways we're like some interesting point that somebody made was that you get humans, you get like a superhumans by just averaging humans. So like I guess I'm not an expert, so like it sounds plausible. I mean, the fact is that like if you average human faces, they become attractive, which is like interesting phenomenon. Which basically you smooth away the irregularity, so they cancel out, and you get like really nice attractive faces. So it's and for similar reasons, like when you average humans, you get rid of the deleterious alleles. So and the deleterious alleles are basically like things that keep us from our potential. So in that sense, you're just like, what could be like? It seems like not so drastic thing to just start averaging humans. Like in some ways, we naturally do that anyway.
Isn't this what communities, organizations, and companies do by combining a bunch of humans together in some structure?
In an abstract sense, yes. But I think that's like a fairly different sense of averaging. Basically, you're not averaging humans; you're aggregating humans.
Yeah. I was wondering how that compares with averaging. I mean, maybe
but averaging. I was just pointing the specific thing that like the low-hanging fruits in gene editing are actually sound pretty good. It's just like just get rid of the bad stuff, and like why not? Like but like of course, like then you can go beyond, and then you have all this like uncanny valley territories.
Yeah, that's true. Yeah. Okay, so then let me get to my final question for you, which is really the question about action. If you want to, and as I know you do, you want to see to it that humanity can maximize sort of its long-term chances for survival and thriving, optionality, as you call it. What is it that humanity as a whole should do, say decision makers or individuals as well?
Yeah, I think coordination and cooperation. More coordination, more cooperation seems to be like really good. A lot of the problems. I mean, one of my favorite essays is Meditations on Moloch by Scott Alexander and Slate Star Codex, and like it's a book-length essay about coordination problems.
Mm-hmm.
But like a lot of the problems that humanity has, they can be just summed up as their coordination problems and bad mesh equilibriums. So yeah, figuring out how to cooperate more, because and like realizing how much there is at stake. Like if you think that like if you're kind of used to there being like I don't know, the world is at stake, then like just don't forget that like planet Earth is just like a tiny speck in the universe. I mean, Eric Drexler, although like he doesn't like the fact that he likes he doesn't he has Eric Drexler has an interesting point, which I'm kind of ruling now by saying that he doesn't like his ideas to be associated with him because he thinks that ideas spread better if they're not associated with any person. So like there's this idea from somewhere that of Paretotopia, where you have basically you're building utopia with this additional constraint that every step should be like a Pareto improvement. It should like shouldn't make anyone's situation worse. Like I mean, there are some like pathological cases, like somebody just like wants to be the king of the.
But you know that's not always how solving a difficult error landscape works, right? Sometimes you have to nail down.
But the interesting thing is that like we do have like this additional resource that most people are not aware of, which is the rest of the universe, and like the pie is just like so vastly more bigger than anyone who's playing kind of zero-sum games and kind of defecting.
Well, that totally makes sense if the pain point that people feel is resources, which it is currently. But I mean, there are other possible pain points, like we talked about. What if, if there is a change in some set of or subset of people, and that is somehow different, and there could be some pressures that are experienced as painful to some other subset of people. So these sorts of pain points, if you want to avoid all of those as well, that can be difficult.
Yeah. So like more general, like there are some like values that are zero sum in some sense. So like those values are going to be a problem no matter how much resources we have. So the idea is to kind of like try to satisfy them by kind of segregation. Like everyone who wants to be the king of the world can have their own world in
their own planet.
Yeah, their own planet. So like and like just accept the meta value that like other like you shouldn't kind of have like increased optionality. You're going to have like way more optionality than you have now, way more resource than you have now, way better future than even considered. It's just not going to be like relatively good compared to others. Like everyone else is also having a great time.
Yeah, by pointing to the universe, one big important thing that you've mentioned there is perspective, because in addition to cooperation, I think perspective is extremely important. Having a good perspective on what's really going on, not just being focused on what you think is super important right at this very moment. And that I think is, I think that's a big problem. Is long-term thinking is not very common.
So that's
and probably because our lives are short.
That's one of the reasons why I'm being like somewhat cautiously, but still pushing the AI risk as framing it more like an environmental risk than social risk, because like social risks. If you say that like AI could be like really bad for society, which is true, it also creates like really bad competitive intuitions in people. It's like, I want like my social values trump over like Chinese social values, and that's just not great. It's way better to frame it as a problem that we have in common, and like environment is like one thing that we have in common. So that in that sense, like that framing is better, I think.
So framing could be an important thing to work on. Better frame problems. Yeah. Okay. Well, thank you. This was extremely interesting. And as I mentioned very much at the beginning, we could have gone off for hours in just one direction, how do you think about good or something like that. So that was wonderful. Thank you. Thank you so much.
Thank you very much.
Okay.
And good luck.
I'll stop recording now.